Hello friends, welcome you all, and today's topic is non-deterministic finite automata, or you can call it as NFA. Today I'm going to discuss the mathematical definition of NFA. First of all, I will tell you something about NFA. My dear friends, I will tell you that this is more flexible. This is more flexible and easy to design in comparison to DFA. What kind of flexibility is it provides that you can understand if I take some examples. So first, I will discuss the mathematical definition of this NFA, and then we will take some examples. So it is if I'm considering non-deterministic finite automata as one machine, then it is again five tuple machine. It is again five tuple machine like DFA, and the tuples are also exactly same. The only difference is transition function. The only difference is transition function, and what is the difference? I will tell you. So, as in DFA, capital Q represents set of all possible states. So here also it is set of all possible states. Then sigma is set of all input symbols. Then delta is transition function, and this is the only difference between NFA and DFA. And Q0 is initial state of the machine. Then F is the same set of final states. So these five tuples are same. The only difference is there in the transition function. Only difference is there in the transition function. For NFA, transition function is we are getting one state, we will see current state of the NFA, and we will see current input to the NFA. And based on that, we can have any subset of Q, and set of all subset of Q can be represented as power set of Q. So this is the power set of Q. So in case of NFA, the transition function is Q cross sigma gives to power set of Q. While in case of DFA, it was Q cross sigma for the I'm writing here for DFA, transition function was Q cross sigma gives Q only, Q itself. But here in NFA, it is Q cross sigma gives power set of Q. Now, power set of Q, what is power set of any set? The set of all subsets of a given set is the power set of that set. So, subset means there may be more than one states. There may be more than one states. So this means there is some certainty. Like for example, I will show you the difference clearly. In case of DFA, suppose I am on Q0 and I am getting 0. In case of DFA, if I'm on Q0 and I'm getting 0, I'm reading 0. So I can be any one state only. So like Q1, Q2, Q3, Q4, any one state would be there in case of DFA. Because for each combination of current state and current input symbol, there exists only one next state. For DFA. While in case of NFA, what we can have here, suppose we are on Q0, initial state of NFA, and we are reading 0. Then we can be in Q0 or Q1 or Q2 like this. So we can be any of these three states. So here in case of DFA, I must write here DFA and here NFA. Here, NFA. So now you can say DFA, for DFA, we are having only one state here at the right hand side. But in case of NFA, we can have more than one state at the right hand side. That means this is any subset of Q, any subset of Q. So that is, and the set of power set of set of all subsets of Q is power set. So we have represented this as power set of Q. So this is the difference. And because of this property, the non-deterministic finite automata is more flexible. Non-deterministic finite automata is more flexible. So I hope, friends, it would be very much clear to all of you. And if you have any doubt, you can comment me, and I will definitely reply your comments. And now I will take one example of NFA. So now, friends, we are going to discuss one example of NFA. And before discussing an example, I must tell you, like for any, as I told you, it is very much easier to design an NFA compared to DFA for any given strings, set of strings. Now, once you design NFA, then you can definitely convert it to DFA, because for every NFA there exists equivalent DFA. So if you can design NFA for such set of strings, then definitely you can convert that NFA into DFA, and that process also we will discuss in further videos. So now I'm going to take to create a machine. We have to create one NFA for accepting all strings of A and B ending with ABB. That means you need to identify the shortest string of this set. So definitely this is ABB. And one more important thing, you need to identify what are the possible input symbols. What are the possible input symbols? So it is mentioned over here clearly that strings of A and B. So only two possible inputs are there. One is A and other is B. And now the shortest string of this set is ABB. ABB. And before this, anything may be there. So what I can say here, so I can start with again with the same flow, like A, then B, then B, and then final state. Now, before this ABB, before this ABB, I can have any A and B, any combination of A and B. A comma B I have written here. So now this is NFA. This completes the NFA. In NFA, you need not to specify all transition for all the states. So this is called NFA. This is called NFA. And you can see here how it is NFA. So you can see for at least one state, one transition rule must be there, like this. Like for initial state, here we have, if I make it Q0, if I make it Q1, Q2, and Q3, then if I see here Q0, if I'm on Q0 and I'm getting A input symbol A, then I can be on Q0 itself, I can be on Q0 itself, or I can be on Q1. So there are two choices there, Q0 and Q1. And because of this state only, this becomes NFA. This becomes NFA because there are two possibilities for next state. So this is NFA. I hope, friends, it would be very much clear. And if you have any doubt, you can write me in comments. Now, again, I will tell you to design an NFA for all the strings of A and B having substrings as AA. at least one occurrence of AA must be there. So what is the, again, we will start with the same logic. We will create one string for one FA for shortest string. We are finalistic. Now, before this AA, any combination of A and B may be there. After this AA, any combination of A and B may be there. So this is what is your NFA. This is your NFA. Now, why it is NFA? If I name all these states as A, B, and C, you can see we are having one transition here on A. If we are having A, small a, then we are having two possibilities. We can remain on state A or we can move to state B. So this becomes the NFA again. This becomes the NFA again. So this is very much easy to create uh, NFA like this. And definitely, if we can create NFA, then we can convert it to equivalent DFA also. And that process I will tell you in further videos. Thank you so much. I hope it is very much clear, and you can ask your doubts in your comments. So I will definitely reply these comments. Thank you so much. Thank you.